we are looking at the idea of if we take a variable and decide to either combine it with another variable and look at the combinations of those variables, or to alter all the values in some way, like add 10 to all the values. So that's what this section is about. It was supposed to be in the last chapter, so it's not going to fit so nicely into the stuff we talked about. We've been talking about during the rest of this chapter, but roll with it. So we're going to start. We're going to start with the easy part, which is if we add, subtract, multiply, or divide by a constant. So let's say that we have this distribution. So vehicle will go from 2 to 6 passengers. And let's say we have $150 per passenger. So one of the things we did was we were able to say that the distribution of that variable, the amount of money that you make, if we have 2 passengers and we charge $150 a piece, how much are we going to make? $300. Right? Because $150 for each person. And then we could go through each one, and the proportion of times that we make $300 would be the same as the proportion of the times that we have 2 passengers, because they're the same outcome, just listed as a different variable. And so that's what the distribution looks like there. Hold on, go back. And you have on your paper what the distribution looks like for the amount of money that you make. So what I want you to do is for each of these, I want you to calculate expected value. We talked about how to calculate expected value in the last chapter. I will start you off in case you forgot. Expected value for X. It should be value times probability of it happening. So 2 times probability of 2 plus 3 times probability of 3, all the way up to 6 times probability of 6, which is 0.05. So I want you to take that and do that for each of the tables. So this is the formula for expected value for the number of passengers. And the other one is expected amount of money that you're going to make. So calculate that expected value as well. And you might be able to predict what this expected value for the income is going to turn out to be. Once you get this expected value for X, see if you can predict what the expected value is going to be for the income, and then do the calculation and see if you're right. Or do both calculations and see how one turns into the other. This first one you should get 3.75. There's the other table. this part of what we're talking about is actually a review. It is something that we talked about all the way back in chapter 2. The new stuff is coming out.
What are we supposed to find after we find the expected value?
I want you to find the expected value for this table, for the cost. And remember, this value should be a mean. So this is the mean amount of passengers that we are expecting to get. The expected value here should be the amount of money on average that we are expected to make. So make sure that that answer makes sense for an expected amount of money if that's how much we make each of those amounts. So if I tell you the expected value of the number of passengers is 3.75, how can I go from there, if I just told you that that was the expected value, how can I go from there and get the expected value for the cost?
Can you just multiply 3.75 by 150?
You can. You can multiply 3.75 by 150. Because all we're doing is we're taking all the numbers and multiplying them by 150. So we can just take the mean and multiply it by 150. And you'll notice that that happens for the standard deviation as well. Because if you think about the amount of spread, it was very narrow, right? It only went from 2 to 6. But then it got a lot more spread out. Now the range of values is from 300 to 900. Lot larger spread. So if we just take all the values and multiply them or divide them by a certain amount, then that amount is going to get multiplied to the mean. It's going to get multiplied to the standard deviation. So the center is going to get multiplied. Spread is going to get multiplied. Now, I want you to make a new table here. This is how much Pete makes. Now I'm going to tell you that his expenses, the amount that he has to pay per day, is $100 fee for upkeep of the Jeep and other such things. So if he has $100 of expenses, give me a table for the net amount of money that he makes. And make a guess for what the mean and standard deviation are going to be for that table. And then do the calculation for expected value. We use N for net amount of money. So I'll give you a hint. The first value made 300 but had to pay 100 back, so that gives an outcome of $200 in net profit. Still has a probability of 0.15 of happening. And then fill out the rest of the table. again, you should have an idea of what's going to happen to the mean and what's going to happen to the standard deviation. So make a guess before you do your calculation, and then do the calculation and see if you were right. All right, first of all, the mean here was $562.50. What's the mean of the net profit going to be? 462, because no matter what value, we're just subtracting 100 from it. What's going to happen to the spread, to the standard deviation? So we're thinking down 100 to $63.50?
It's gonna stay the same.
You're saying it's going to stay the same. Why do you say that?
Because all of them are reducing by 100, so standard deviation shouldn't change.
Where's it thought?
Aren't the probabilities all staying the same?
Probabilities are all staying the same.
So it changed for the first one because you're multiplying, but this one you're subtracting, so I also think it's the same.
You're also thinking they're going to stay the same? It stayed the same. Here's the reason. And again, we did this form of this in chapter 2. Here's the values. Okay? And well, actually, we're gonna take 100, so we're gonna move it to your left. Okay. So here are the values over here. And so if we're subtracting 100, all that's happening is that all the values are still going from this range to this range, but they're shifting over here. And so the smallest and the largest value are still as far apart as they were. Standard deviation is average distance from the mean. These values are still as far away from the mean as they were. It's just that the mean also moved along with it. So to recap, I skipped some bits here. So multiplying or dividing, multiplies or divides the mean, multiplies or divides the standard deviation. If we are adding or subtracting is going to add to the center, the mean or the median, but it does not change the spread, like your standard deviation. Doesn't change the shape either. So, to bundle all of that together, if we have a linear transformation, then the effect on the mean and standard deviation if we have a plus bx, what's going to happen to the mean? So now we're multiplying and we're adding. What happens to the mean? Does it get multiplied? Yes, it does. Does it get added? Yes, it does. How about the standard deviation? Does it get multiplied? Yes, it does. Does it get added? No, it doesn't. It's adding or subtracting doesn't change the center of the spread, so it only gets multiplied. Same shape. The mean gets the adding and subtracting and the multiplying and dividing. The spread only gets the multiplying. does not get the adding. So any questions on that so far? Anyone need me to go back to anything? Because I know I just breezed through like 4 slides. Okay, let's bring this into an example. Temperature of the water follows a normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. Define the random variable y to be the water temperature in degrees Fahrenheit. 'Cause this is America. We're not in Celsius. Like those Canadians or Brits. So, and most of the rest of the world, don't worry about it. America. There's your formula for conversion from Celsius to Fahrenheit. So for part A, we want to know what the new mean and standard deviation is going to be. So random variable y, so we're going to have the mean of y so all the numbers are going to get multiplied by 9/5 and you're going to get 32 added to it. So what should I do to the mean? Should I multiply by the 9/5? Yes, I should. Add 32 to it?
Yes.
Yes, I should. 9/5 times the mean was 34. And I do want to add the 32 to it. Someone multiply for me. 93.2. 93.2? Fahrenheit. Standard deviation. What should we do? Only multiply for a spread, not adding. So we are going to take 9/5 times our standard deviation was 2. We're not going to add the 32 because just adding or subtracting a number doesn't change standard deviation. So 9/5 times 2, 18/5, so that is 3 points. Okay. Part B. Let's see if we remember our normal distributions. Let's draw the normal curve. Our mean was 93.2. Standard deviation was 3.6. Give me 2 standard deviations on either side. What do we want to shade? from 90 to 100. So start at 90, end at 100. We want between 90 and 100. Here's the area that we want. If we're doing it with z-scores, this z-score should be negative. This, because it was below the mean of 93.2, this z-score should be positive. (100) minus the mean of 93.2 over the standard deviation of 3.6. And then same thing over here. So get out those z-scores, and I will get out the calculator. Binomial or not binomial? Second, distribution. It's going to be normal CDF. And since we're not just shading anything to the left or anything to the right, we are actually having a start and end point here on this picture. Our lower bound should be our lowest score, our upper bound should be our higher score. So there's two different ways that you can do this. If you get the z-scores, what's my z-score for the lower? This should be the one that was negative. The one that you got calculated for 90. What did we end up with? Negative what?
As a fraction or decimal?
Decimal.
Negative 0.89.
Yeah.
Negative 0.89. Upper. So the z-score for 100.
1.89.
1.89. Since we're working in z-score land, mean is 0, standard deviation of 1. There's your percentage. The other way you can do this, which might be quicker for some of you, is if you want to put in the mean and standard deviation, mean was 93.2, and standard deviation is 3.6. Then you can just put in your lower as 90 and your upper as 100, and it'll do the z-score stuff for you. And it should give pretty much the same answer, maybe with some very small rounding stuff. Questions on that? All right. Homework assignment. I'll come back to it in a minute. But there's one more thing I want us to do today. So I want to get you started on it, and then I'll put the homework back up. Another bit of tours. This is what I want you to try. I want you to get something for the variable t equals x plus y, where x plus y is the total number of passengers on each of their tours. So I will get you started in making this table. There was actually a question similar to this on the practice multiple choice that we did. So we want t, probability of t. What is the smallest amount of combined passengers we can have on the tour? Combined. The smallest from here is 2. The smallest from here, also 2. So in total, the smallest amount of combined total we can have is 4. What's the largest we can have? 11 if we have 6 and 5. And all the values in between are possible. And again, I'll get you started. To get 4, we have to have 2 and 2. So the first one has to be 2, that's probability of 0.15. And the second one has to be 2. What's the probability of the second one being 2? 0.3. So we have 0.15 times 0.3. Now the other one is going to be harder, because you have to think about 2 different possibilities to get 5. We can have 2 here and 3 here, or we can have 3 here and 2 here. So we got to figure out each of those individually and put them together to get probability of 5. And where we're eventually just going to get is, and what we'll talk about on Monday, is what's the expected value of t. So I will let you work on that and get this table and get it filled out. There's the homework again if you need it.